Good morning everyone. In this video, we will talk about the different differentiation rules in calculus. This video will be divided into 3-part series. For the first part, we will talk about the differentiation rules for algebraic functions. For the second part, we will talk about a specific rule which is chain rule. And lastly, for the third part, we will talk about the differentiation rules for trigonometric, exponential, and logarithmic functions. So let's get started then. In the first part, we're going to go over the differentiation rules for algebraic functions. The first rule is the constant rule. The derivative of c, where c is a constant, is simply 0. For our example, y is equal to 43, f of x equal to 25, and y is equal to 102. The derivative of these are y prime is equal to 0, f prime of x is equal to 0, and y prime is equal to 0. Just simply remember, if the function is a constant, then the derivative is 0. Next is the power rule. The derivative of x raised to n is equal to n times x raised to n minus 1. So for number 1, f of x is equal to x raised to 4. We bring down 4 to the front as a coefficient. So f prime of x is equal to 4x, then reduce the power by 1. So instead of x raised to 4, it will be x cubed. So the final answer is f prime of x is equal to 4x cubed. So for number 2, y is equal to x raised to 4 thirds. Still, same steps applied. We bring down 4 thirds to the front and reduce the power by 1. So y prime is equal to 4 thirds times x raised to 4 thirds minus 1. The answer would be y prime is equal to 4 thirds times x raised to 1 third. Expressing the fractional exponent as a radical, the final answer is y prime is equal to 4 times the cube root of x over 3. Another rule is the constant multiple rule, where the derivative of c times f of x is equal to c times the derivative of f of x. So for number 1, y is equal to 9x raised to 4. So to get the derivative of this, y prime is equal to 9 times the derivative of x raised to 4. By applying the power rule on x raised to 4, y prime is equal to 9 times 4x cubed. So the final answer would be 36x cubed. So for number 2, f of x is equal to 7x raised to 5. To get the derivative of this, f prime of x is equal to 7 times the derivative of x raised to 5. By applying the power rule on x raised to 5, x prime of x is equal to 7 times 5x raised to 4. So the final answer would be f prime of x is equal to 35x raised to 4. Let's move on to the sum and difference rule. The derivative of f of x plus or minus the derivative of g of x. Getting the derivatives of each term and considering the operation in between. So for number 1, f of x is equal to x raised to 4 plus 2x cubed minus x squared plus 4x minus 1. So f prime of x is equal to the derivative of the first term, 4x cubed, plus the derivative of the second term, 6x squared, minus the derivative of the third, 2x, plus the derivative of the fourth, 4, minus the derivative of the last is 0. Since 0 is nothing, we can just get rid of it. So here's our final answer. So for number 2, y is equal to 4x raised to 5 minus 2x cubed plus 5x raised to negative 5. So y prime is equal to the derivative of the first term, 20x raised to 4 minus the derivative of the second, 6x squared, and the derivative of the last is negative 25x raised to negative 6. And rewriting it as a positive exponent, since there is a negative exponent, the answer would be y prime is equal to 20x raised to 4 minus 6x squared minus 25 over x raised to 6. Next rule is the product rule, where the derivative of u times v, where u and v are two different functions, is equal to uv prime plus vu prime. So for number 1, y is equal to the quantity of x squared plus 1 times the quantity of x cubed minus x plus 5. We represent the first function as u and the second function as v. So u is equal to x squared plus 1 and v is equal to x cubed minus x plus 5. So u prime is equal to the derivative of this, which is 2x, and v prime is equal to the derivative of this, which is 3x squared minus 1. And then we will apply the formula y prime is equal to uv prime plus vu prime. We just have to substitute each of these values to this given formula. So now we have y prime is equal to the quantity x squared plus 1 times the quantity 3x squared minus 1 plus the quantity of x cubed minus x plus 5 times 2x. By simplifying this, y prime is equal to the quantity 3x raised to 4 minus x squared plus 3x squared minus 1 plus the quantity 2x raised to 4 minus 2x squared plus 10x. By combining similar terms, y prime is equal to 5x raised to 4 plus 10x minus 1. Our last rule is the quotient rule, where the derivative of u over v is equal to vu prime minus uv prime all over v squared. For example, f of x is equal to x squared plus 1 all over 3x minus 2. We represent the numerator as u and the denominator as v. So u is equal to x squared plus 1 and v is equal to 3x minus 2. And u prime is equal to the derivative of this, which is 2x, and v prime is equal to the derivative of this, which is 3. And we will apply the formula f prime of x is equal to vu prime minus uv prime all over v squared. After substitution, we'll have f prime of x is equal to the quantity 3x minus 2 times 2x minus the quantity x squared plus 1 times 3 all over the quantity 3x minus 2 squared. And by simplifying, we'll have the quantity 6x squared minus 4x minus the quantity 3x squared plus 3 all over the quantity 3x minus 2 squared. And by combining similar terms, the answer will be f prime of x is equal to 3x squared minus 4x minus 3 all over the quantity 3x minus 2 squared. For the second part of our three-part series, we're going to discuss the chain rule. So for the chain rule, if u is equal to g of x and y is equal to f of g of x, then dy over dx is equal to dy over du times du over dx. So for number 1, y is equal to the quantity 6x minus 4 cubed. We let the inside function be equal to u, so u is equal to 6x minus 4. And now the function will be y is equal to u cubed. Now we have to find the derivative of y with respect to u, so dy over du is equal to 3u squared. Now we take the derivative of u with respect to x, so du over dx is equal to 6. By applying the formula of chain rule, dy over dx is equal to dy over du times du over dx. We just simply have to substitute the given values here to the given formula. So dy over dx is equal to 3u squared times 6. Since u is equal to the inside function, we will substitute it back here. So it will be 3 times the quantity 6x minus 4 squared times 6. Then we multiply 6 and 3, it will be 18 times the quantity 6x minus 4 squared. And it is now our final answer. So for number 2, y is equal to the quantity 4x cubed minus 1 raised to 5. And the faster way to get the derivative of this is by using the power rule just for the outside function and leave the inside function as it is. So dy over dx is equal to 5 times 4x cubed minus 1 raised to 4 times the derivative of the inside function, which is 12x squared. So we multiply 12x squared by 5 and the final answer would be 6x squared times the quantity 4x cubed minus 1 raised to 4. So for number 3, y is equal to the square root of x raised to 4 plus 1. And how do we get the derivative of this? Remember that this could be expressed as a fractional exponent. So y is equal to x raised to 4 plus 1, the quantity raised to 1 half. Now we can perform the chain rule here. So dy over dx is equal to 1 half times the quantity x raised to 4 plus 1 raised to 1 half minus 1, which is negative 1 half, times the derivative of the inside function, which is 4x cubed. And by simplifying it a little bit, dy over dx is equal to 4x cubed over 2 times the quantity x raised to 4 plus 1 raised to negative 1 half, So for further simplification, dy over dx is equal to 2x cubed times the quantity x raised to 4 plus 1 raised to negative 1 half. And we can express this as a positive exponent. It will be dy over dx is equal to 2x cubed all over the quantity x raised to 4 plus 1 raised to 1 half. And we can express this into radicals, and the final answer will be dy over dx is equal to 2x cubed all over the square root of x raised to 4 plus 1. And that's it. So for the last part of our three-part series, we will tackle about the differentiation rules for trigonometric, exponential, and logarithmic functions. So now let's go first to the trigonometric functions. The differentiation rules for the trigonometric functions are as follows. The derivative of sine u is equal to cosine u times du over dx. The derivative of cosine u is equal to negative sine u times du over dx. The derivative of tangent u is equal to secant squared u times du over dx. The derivative of cosecant u is equal to negative cosecant u cotangent u times du over dx. The derivative of secant u is equal to secant u tangent u times du over dx. The derivative of cotangent u is equal to negative cosecant squared u times du over dx. Notice that the function cosine u, cosecant u, and cotangent u have negative in their derivatives. So, functions that start with c have negative sign in their derivatives. Notice that tangent u and cotangent u have squares in their derivatives. So, functions that has tangent in their names like tangent and cotangent, it means there is squared in their derivatives.
Notice that the derivative of tangent has secant on it. If you remember the Pythagorean identity, 1 plus tangent squared theta equals secant squared theta. The partner of tangent is secant. So if you remember the identity, you might easily remember the derivative of tangent. So for cotangent, the partner in the identity 1 plus cotangent squared theta equals cosecant squared theta. So if you remember the identity, you might remember the derivative of cotangent. So you may also remember if for cosecant and secant by remembering the identities. So for cosecant, it has cosecant u, cotangent u, and for secant, it has secant u and tangent u. Last reminder is don't forget to multiply the derivative of the angle.
For number 1, f of x is equal to secant times the quantity 3x plus 1. Then we find the derivative of secant, which is f prime of x is equal to secant times cotangent times the derivative of the angle, which is represented by du over dx. Next, we copy the angle for secant and cotangent, and it will be f prime of x is equal to secant 3x plus 1 times cotangent 3x plus 1 times the derivative of the angle 3x plus 1, which is 3. So the final answer is f prime of x is equal to 3 times secant 3x plus 1 times cotangent 3x plus 1. And that's it. So for number 2, f of x is equal to 7 times tangent x squared minus 5 sine 2x plus 4 cosecant 4x. To get the derivative of this, we have to get the derivative for each terms. So for the first one, 7 times the derivative of this, which is secant squared x squared times 2x minus the derivative of the second term, which is 5 times the derivative of this, which is cosine 2x times 2 plus the derivative of the last term, which is 4 times the derivative of this, which is cosecant 4x cotangent 4x times 4. And by simplifying it, it will be f prime of x is equal to 14x secant squared x squared minus 10 cos 2x minus 16 cosecant 4x cotangent 4x. And by factoring out the 2, f prime of x is equal to 2 times the quantity 7x secant squared x squared minus 5 cos 2x minus 8 cosecant 4x cotangent 4x. And that's our final answer. Let's move on to exponential functions. Differentiation rules for exponential functions are the following. The derivative of e raised to x is equal to e raised to x, and the derivative of e raised to u is equal to e raised to u times du over dx. So for number 1, y is equal to e raised to 4x plus 7. To get the derivative of this, we have to copy e raised to u, which is e raised to 4x plus 7, times the derivative of the exponent, 4x plus 7. And our final answer will be 4 times e raised to 4x plus 7. So for number 2, y is equal to negative 4x squared e raised to x plus 5x e raised to x minus 10e raised to x. To get the derivative of this, we have to get the derivative for each term. So we let negative 4x squared be u and e raised to x be v. By the product rule, y prime is equal to negative 4x squared times e raised to x plus e raised to x times negative 8x plus the derivative of the second term. We let 5x be u and e raised to x be v, and the derivative will be 5x times e raised to x plus e raised to x times 5 minus the derivative of the third term, which is 10e raised to x. And by simplifying it, the answer will be y prime is equal to negative 4x squared e raised to x minus 8x e raised to x plus 5x e raised to x plus 5e raised to x minus 10e raised to x. And by combining similar terms, y prime is equal to negative 4x squared e raised to x minus 3x e raised to x minus 5e raised to x. We then factor out e raised to x on each term, and our final answer will be y prime is equal to e raised to x times the quantity negative 4x squared minus 3x minus 5. And that's it. And lastly, the logarithmic functions. Differentiation rules for logarithmic functions are below. The derivative of ln u is equal to 1 over u times du over dx. And the derivative of log u with base b is equal to 1 over u ln b times du over dx. For number 1, y is equal to ln x cubed. By applying the formula above, dy over dx is equal to 1 over x cubed times 3x squared. And by simplifying it, it will be 3x squared all over x cubed. Since they have common base, we can still simplify it, and our final answer will be dy over dx is equal to 3 over x. So for number 2, f of x is equal to 2 ln of the quantity 3x squared minus 1. To get the derivative of this, it will be dy over dx is equal to 2 times the derivative of ln of the quantity 3x squared minus 1. How come? Because of the constant multiple rule. By applying the formula above, it will become 2 times 1 over 3x squared minus 1 times 6x. So by simplifying this, our final answer will be 12x over 3x squared minus 1. And another example is y is equal to logarithm of 5 minus 2x with base 7. We apply the formula above to get the derivative, which is dy over dx is equal to 1 over the quantity 5 minus 2x times ln of 7 times the derivative of this, which is negative 2. And by simplifying it, our final answer will be dy over dx is equal to negative 2 all over the quantity 5 minus 2x times ln of 7. So for our last example, f of x is equal to logarithm of tan 2x with base 5. By applying the formula above, dy over dx is equal to 1 over tan 2x times ln of 5 times secant squared 2x times 2. And by simplifying it, our final answer will be dy over dx is equal to 2 sec squared 2x all over tan 2x times ln of 5.